Alright guys, we're going to do a video here on classifying. And one thing we want to just start off with is making sure we know what we mean when we say classify. So when we classify geometric figures, we're really just identifying the most specific name or category that we could place that figure into. So classifying, we'll just kind of in a simple, non-mathy way, we'll say classifying is just identifying. In triangles cases here, we're going to identify the type of triangle. That's kind of our most simple definition, not even really definition, but that's what we're doing. So classifying triangles, you're going to be given a triangle and asked to identify what type of triangle is this. So we have to examine some of the properties of the figure and see exactly how specific we can get with naming the figure. So to classify a triangle, we're going to need to consider a few things. We might need to consider the length of the sides, or the measurement of all the angles. So we're going to look and see if the lengths of the sides or the measurements of the angles can tell us enough information to classify, to give the most specific type of name for that triangle. So when we calculate the sides, remember most of the time we saw just in our last video that we did that we're going to, when we were examining the length of segments on the coordinate plane, we're going to use the exact same skills here to find the length of the sides of a triangle. We're going to either use Pythagorean theorem on the graph, so that's probably what we'll do most of the time, or we can use the distance formula. So we could use the actual coordinates, and I could find the distance between any 2 points that way, and I could do that 3 times. So I could use my equation 3 times. We'll probably use Pythagorean theorem most of the time because these will be points that are given to us that we could plot pretty easily. So once we plot these things on the coordinate plane, we are going to find the length of all 3 sides, and once we do that, we're going to make a classification. So an equilateral triangle, that would be a triangle that has, let's say a triangle with 3 equal side lengths. An isosceles triangle, again, we're going to take our triangle in the coordinate plane, find the length of all the sides, and an isosceles triangle would be a triangle with exactly 2 equal side lengths. In a scalene triangle, after I find the length of all 3 sides, if I determine that the triangle, and I have a computer problem here. A scalene triangle would be a triangle with 0 equal side lengths. So if I find that the lengths of all 3 sides are all different, there's none that are the same, there's no congruent sides, then that would be a scalene triangle. We are going to be doing in our class these 3 classifications primarily. Okay, so that's where we're really going to be doing our work. I will point out that we could also classify triangles based, part of the classification to be even more specific, I guess, would be to utilize the angle measurements also. So a right triangle, I think we know what a right triangle is. A right triangle is a triangle with one 90-degree angle. An acute triangle, we know an acute angle is less than 90. So an acute triangle would be a triangle with all 3 angles measuring less than 90 degrees. And an obtuse triangle would be a triangle with one angle greater than 90 degrees. Right? And remember, we can't have more than one angle bigger than 90 because that means two of the angles would be over 180 by themselves, and we know all three of them together have to add up to 180, so that's not a possibility. So we're not going to deal too much with classifying acute, obtuse, or right triangles, but focusing more on the equilateral, isosceles, and scalene classifications. But I wanted to point that out before we move on. So just two quick, well, they're not super quick actually, but two examples. Okay, so classify the triangle with coordinates A, B, and C with the given point, with the given coordinates, and classify. So we're going to plot these first. So A is at point 1, 3. So 1, 3 is point A. B is at 3, 1. Point B. And C is -2, -2. And that's point C. So I'm going to make my triangle here. I'm going to kind of just shade it in so it shows up a little bit better. And now we need to find the lengths of all three sides. So I'm going to start with, actually, let's just do it in order, probably make the most sense. So we're going to find the of all sides. So AB, right? Let's find the length of side AB. So I'm going to make a triangle here and use Pythagorean theorem. So this side is 2 and that side is 2. So I can find, right, the measurement of AB by using Pythagorean theorem, right? A and B would be the 2's, and C, the side I don't know, would be like this one right here, that segment AB. So I know 2 squared plus 2 squared equals C squared. Right? And C is the length of AB. So 4 plus 4 equals C squared. 8 equals C squared. So I don't want C squared, I want C. So I'm going to take the square root of both sides, and C is the square root of 8. So I could make that a decimal if I wanted to. There's no number that's going to come out, the whole number, integer, that's going to come out exactly to 8, but leave it in radical form for now. Then we want to find the length of our next side, which would be BC. So from B, let's do it in a different color actually. So BC would be this side right here. So we're going to make a triangle, and BC, that's going to be the hypotenuse. So we know this side on the bottom is 1, 2, 3, 4, 5 units, and this is 1, 2, 3 units. After you do Pythagorean theorem enough, you'll start to see some patterns here, but we're going to keep going. So we have 3 squared plus 5 squared equals C squared. And I'm just going to follow my same steps here. So 3 squared is 9, 5 squared is 25. Add them together is 34. So 34 is C squared, and I take the square root of both sides. So C is the square root of 34. And then my last side is side AC or CA. Do that one in blue. Make a triangle. This vertical side is 1, 2, 1, 2, 3, 4, 5. And the horizontal side on top is 1, 2, 3. So I can do Pythagorean theorem on this side also. So 3 squared plus 5 squared equals C squared. And if I look, AC and BC are the same numbers, so we're going to end up with the same result, but we'll just kind of finish it off here for practice. Right, so square the 3 and square the 5, then I add them together. Take the square root of both sides. So the square root of 34 equals, right, square root of c squared would be just a c. So I found the length of all three sides. And what did I discover? Well, I have square root of 8, square root of 34, and square root of 34. So two of them are exactly the same. So my final conclusion here, my classification, this is a isosceles, man, my isosceles triangle. My isosceles triangle has two equal lengths. Okay, so you can kind of see the process is not super fast. You know, you'll start to see patterns. Like I was saying, like here I can see when I made my triangle, my slope triangle, you know, similar to my Pythagorean theorem numbers were 3 and 5, and I had the same thing here. So once you see that the numbers are the same, you know the result is going to be the same. So you will start to find little tricks of the trade here, but for now we want to make sure we show all of our work. Okay, we're going to do one more. I would say quick, but it's not as quick as some of the other problems that we might be able to do. Okay, so example 2, last one, classify this triangle with the given vertices, triangle LMN. So L is at -3, -2, -3, -2, this point L. M is at 3, 3. And N is at 4, -3. I'm going to connect all those. I'm going to kind of just shade that in so we can see it a little bit more clearly. And I could use the distance formula, right? I could, for example, to find the length, I'm going to find the length of all three sides. So let's find the length of LM. Right? I'm going to use Pythagorean theorem, but I could use the distance formula and use the points L and M and call that x1, y1 and x2, y2 and use my distance formula. I can find the difference in the y's. If I look here, actually maybe I'll do the distance formula just for one of these so we can see how it works. So LM, if I use the distance formula, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance for those is the square root of x2 minus x1. So x2 is 3 and x1 is -3. So 3 minus -3 plus y2, which is 3, minus y1, which is -2. So we have two negatives, which is going to make a plus. So this is going to equal the square root. Oops, I forgot my squares here. 3 minus -3 is 3 plus 3 is 6 squared plus 3 minus -2 becomes 3 plus 2, so 5 squared. So the length of LM is the square root of 36 plus 25, which is 61, square root of 61. So just going to do one of those sides to show you how the distance formula could be used. Right? I think for most of us, it's going to be a little bit faster probably to use Pythagorean theorem. It's really the same thing, but it's a little bit more visual. So we found LM, so we found this side on the top left, and now we're going to do MN. So this side right here between M and N. Before we move on, just if I look at that side LM, if I were to make a triangle like this, I would see that I would have 1, 2, 3, 4, 5 in this direction, and 1, 2, 3, 4, 5, 6 in this direction. 6 and 5, those are the two numbers that I was able to find using the coordinates right here. So whichever you prefer. MN though, we're going to go to this pink side, so MN, I'm going to make a triangle. This side's only 1, and then it goes down 1, 2, 3, 4, 5, 6. That one's kind of tough to see, but I'm going to make my Pythagorean theorem here. So I'm going to have 1 squared plus 6 squared equals c squared. Right? C representing the side we don't know, the hypotenuse. 1 plus 36 equals c squared. So 37 equals c squared. So if c squared is 37, c is the square root of 37. And my last side is ln. I'll do it in blue down here, and I'll make my triangle for Pythagorean theorem. So it goes down 1, and then over 1, 2, 3, 4, 5, 6, 7. So 1 and 7. So from L to N, I went down 1, so 1 squared, and I went to the right 7. So 7 squared is c squared. So 1 plus 49 is c squared. So 50 is c squared, and c is the square root of 50. So now I'm going to examine the length of my three sides, right? I have square root of 61, which would, I could get a decimal if I wanted to, but I'm just going to think of it this way for now. Square root of 37 and square root of 50. Those are my three side lengths. None of those three are the same. Those are all different. So if I find the lengths of the sides and they're all different, then I know in the end I can make a conclusion that I can classify that. I'm fitting it down here as a scalene triangle. Okay, so that's kind of our classification of triangles by side length. Again, we didn't look at the angle measurements at all. One thing we can do without even knowing the angle measurements is we can examine the slopes and see if there's any right triangles, because we know that a 90-degree if I maybe scan back up here real quick, a right triangle that would have one angle that's 90 degrees, right? What that really means is that there will be two sides that are perpendicular. Right? And if two sides or two lines, we learned back last semester, if they're perpendicular, that means those sides have opposite reciprocal slopes. So we could look at the slopes of those two, right? The two numbers that we used on the slope triangles and see, do any of them have opposite reciprocals? And that would tell us if it's 90 degrees, and we could determine if it's a right triangle that way. I don't think we'll see any of that right now, but again, that's just something to look forward to in Math 2. All right, so right now, kind of our have-tos. I always like to think of what we have to know. We have to be able to use Pythagorean theorem to find the length of three sides and determine from those lengths, are there 0, 2, or 3 congruent sides? And then, right, that would tell us 0 would be scalene, 2 would be isosceles, 3 would be equilateral.